第39集，能量武士喜欢去哪里？
Meng Meng, are you working on the experiment that I left you last time?
是的，我发现当我把热水倒进冷水杯里的时候，冷水杯里的温度上升了，水也没有那么冷了。我刚才太渴了，能喝杯温水太好了。
Yes, it is important to stay hydrated. So now we know the fastest way to cool down a hot glass of water, right?
是的，我把热水和冷水混合到一起，这样就有了温水。
Very good, Meng Meng. Now you've learned another piece of common knowledge about nature. I can't help but notice, but your room looks pretty neat today. Did you clean it yourself?
是啊，当然了。自从你告诉我，如果我不及时收拾脏乱的房间，它就会变得越来越乱，所以我决定每天都收拾房间。
Good work, Meng Meng. And do you still remember the statistical physics behind it? We've said that there's only one way to keep a room neat, and thousands of ways to make it messy.
我记得就和水里扩散的食用色素一样，它会变得越来越乱。
Correct. And we also had a word to describe the number of ways or extent of the mess. Do you still remember the word?
熵。
Correct. It's entropy in English and shang in Chinese.
对了，你说房间变乱和颜色会扩散是因为运动，所以说是调皮的能量武士把这些东西弄得乱七八糟了吗？
Well, sort of. I told you that after scientists studied energy using entropy, they came upon the first law of thermodynamics. Do you still remember it?
我想想，好像是说能量武士只会跑到其他地方，但不会被消灭。
Almost there. The accurate statement is energy cannot be created or destroyed.
我最喜欢的能量武士又回来了，克里斯博士，我喜欢能量武士，你快多给我讲几个能量武士的故事吧。
No problem. Today we'll continue our studies with the second law of thermodynamics, and I'll tell you where the Energy Warriors' favorite hiding place is.
好呀，好呀。
Children, would you like to know the law of the Energy Warriors movement? Follow me. Let's go. Meng Meng, look at this. We have a glass of cold water and a glass of hot water. I don't want to drink the cold water, and I'm afraid I might get burned if I drink the hot water. What should I do?
这个我知道，你把热水倒进凉水里，将它们混合在一起，就没有那么烫了。
That's a good idea. Children, have you ever done this? Or perhaps you've seen Mom or Dad do it? Do you know the reason behind it? Do you know why the hot water becomes warm after we add it to the cold water?
这是因为凉水把热水变凉了，这个我还真没想过。
Meng Meng. This is what we're about to learn, the second law of thermodynamics.
热力学第二定律，物理学又来拯救我们啦。
That's right. The second law will also tell us how the Energy Warriors run out of the hot water. Would you like to know the reason why?
是的，快告诉我们吧，拜托了。
I love your enthusiasm, Meng Meng. The second law is simple to state now that we have learned the concept used to study energy, entropy. So, the second law says that the entropy always goes from lower to higher.
的确挺简单的，不过这是什么意思呢？
Silly koala. We know that entropy is the number of ways, or the extent of chaos. So, the second law of thermodynamics says that a thing will go from a low number of ways to a high number of ways. Or we can say that the extent of chaos starts at a lower level and goes to a higher level.
混乱程度会从较低的程度发展到较高的程度，所以只有少量的方式让房间干净，而很多种方式让房间变脏乱。那热力学第二定律说的就是干净的房间会变脏乱。
You got it! And now think about the change of color. Are these two the same?
是相同的。食用色素刚滴入水中的时候是聚集在一起的，并没有扩散到很多地方，而当它开始扩散的时候，就能扩散至很多很多地方了。因此，热力学第二定律说的就是颜色会扩散。
Incredible, Meng Meng! You really do understand it. I'm so impressed with all you great learners.
对了，克里斯博士，你还没告诉我，为什么热水加进了凉水就变温了呢？这里面的能量武士到底是怎么跑的呀？
All right, let's follow their tracks now. Children, have you figured out the rule for hot things and cold things? The words we use kind of give it away. Do you remember that heat means movement of energy?
是的，我记得热是因为武士们在变身，从能量武士变成了热能武士，这和热力学第二定律也有关系吗？
Yes. Remember your glass of warm water? The hot water was hot because it had heat energy, or we can say it had heat energy warriors. The hot water and the cold water separated is a low entropy situation. This is just like children in line in a classroom, which is very hard to maintain. When the bell rings, the children go outside to the playground and spread all over the place. This is exactly what happens when the hot water is poured into the glass of cold water. The heat energy gets spread around. This is a high entropy situation.
所以热能武士在一起是低熵，他们跑开了就是高熵。那么热能始终都是从热变冷吗？
Yes. Do you know why the heat spreads out?
扩散开。我知道热力学第二定律。那这是不是就意味着热能一定会从低熵发展为高熵呢？
Good job, Meng Meng. There are many things in our world the second law of thermodynamics can explain. Can you think of some other examples of temperature changing?
比如说冰块融化。
Good example, Meng Meng. When an ice cube sits in a room, its molecules are frozen. There are very few ways the molecules can be. This means the entropy is
低。
good. And liquid water has molecules that bounce all around. There are many ways those molecules could be. The entropy is
高。
And the second law of thermodynamics says that entropy goes from low to high. So yes, you are correct. A melting ice cube is an example of the second law.
热水一定会变冷，冰一定会化成水。现在我终于明白其中的道理了，这都是因为热能武士们太顽皮了，总是到处乱跑，不愿意老老实实的待在那里。
That's right.
但是克里斯博士，水也会变成冰啊！难道热力第二定律也有不适用的时候吗？
You're incredible, Meng Meng. You always find good examples from the opposite side. I should have mentioned that the second law of thermodynamics is about the rule by itself. It tells us that entropy will go from low to high if the system is by itself. To make the process go in reverse requires something external, and that takes work.
这就像我要通过整理房间来改变房间的混乱一样。
Exactly. Kids, have you ever thought about the reason why water can turn backwards into ice? Let's play a game to find out.
亲子游戏。
Children, today we learned about the second law of thermodynamics, which says that things move from low entropy to high entropy. Water as ice is frozen, and that means it has low entropy. Water as liquid has high entropy, so that means that ice melts. But Meng Meng noticed that sometimes water can freeze. How does that work? Luckily, scientists and engineers have figured out the answer. We put it in the freezer. Okay, but why does that work? Well, it takes work. In this case, electrical work. Here I have a power meter. You can ask Mom or Dad to buy one of these at the hardware store for you. I'm going to measure if a glass of water will freeze in the freezer. And we're going to check to see if that takes electrical work. Why don't you try it at home? Put a glass of water in the freezer. What do you think will happen? Will the water freeze? Will the power meter make sure that some energy was used? Let's find out next time. Bye!